Welcome to Mathenatic. In this video, we'll focus on an exam type question for a geometric series. So we are given the following series of 24 over x plus 12 plus 6x plus 3x squared, and that pattern continues. And the question says, calculate the sum to infinity of the series. So for the sum to infinity, we will use the formula of a divided by 1 minus r that we can find on our formula sheet. So a represents the first term in our series, so that is 24 over x, and r is term 3 divided by term 2. Now you can also find r by saying term 2 divided by term 1. But if I do that, I have 12 divided by 24 over x. And some people are not comfortable working with this type of expression. So what I recommend is use the terms that look kind of linear. So you can say r is equals to 6x over 12. And that is easy to simplify to x over 2. So we have our a and we have our r. In order then to find the sum to infinity, we can substitute the values of a and r, even if it is in terms of x, into our equation. So we have a as 24 over x and r as x over 2. And there's quite a bit that is happening here, but let me walk you through it. So we have the numerator as 24 over x, and we are dividing that by 1 minus x over 2. And that is all that we are doing in this first step. We are rewriting this fraction to something that looks a little bit more familiar. This denominator part, or the second part of this division expression, we can try and rewrite these two terms as one term. So 1 can be represented as 2 over 2. And that will create a common denominator of 2. So then we'll have 2 minus x over 2. And then in grade 10, we learned the tip and times rule. So if I change division into multiplication, and I'll flip or tip upside down the expression after the division. So can you see that fraction now is upside down? Meaning the denominator is now the numerator, and the numerator becomes the denominator. And then we have simple multiplication to do. So we say 24 multiplied by 2 is equals to 48. And x multiplied by 2 minus x becomes 2x minus x squared. So we have x times 2, and that is 2x. And then x times negative x, which gives us negative x squared. The next question says, for which values of x will the series converge? Obviously, it needs to be a convergent series for the sum to infinity to exist. And for a convergent series, we know that the ratio needs to be between 1 and negative 1. But we need to be careful. This previous answer represents the sum to infinity, not the ratio. We have calculated the ratio to be x over 2. And that is where we would start. We'd say the ratio is between negative 1 and 1. The ratio is x over 2. And then we need to solve for x. And I simply multiply both sides by 2. So negative 1 multiplied by 2 is negative 2. And 1 multiplied by 2 is equals to 2. So x needs to be between negative 2 and 2. The third question says, if x is equals to 4, determine the sum of the sequence to 15 terms. So now they are changing the question slightly. It's no longer a sum to infinity, but they give us x is equals to 4. So in our original question, we had 24 over x as our first term. So that represents our a value. And our ratio is x over 2. So let's use that information. So the a value is 24 over x, and x is now 4. So therefore the first term is 6. And the ratio was x over 2. So therefore the ratio is equals to 2. And we want to find the sum to the 15th term. So we can't use this previous answer of the sum to infinity. So just be careful. What we rather need to do is use the formula for a geometric series that we can find on our formula sheet. So we would substitute A with 6 and R with 2. The n value is 15. And once you've done all the substitutions, remember there's a R in the denominator as well, then you can use your calculator to find the sum to the 15th term is equals to 196,602. Thank you for watching. Support us by liking and subscribing to Mathenatic. Check out our Digistore for math study notes, with free downloads for statistics and financial math. Follow the link in the video description.